Now we will discuss about foreground wait sections. Foreground waits are displayed in 3 separate sections in AWR Report. Top 10 foreground events by total wait time, which can be found at the top of the report. After you scroll down through some of the other section, you would also find Foreground Wait Class section and Foreground Wait Events section. Top 10 foreground events by total wait time section provides lists the top 10 wait events that have consumed the most total wait time, giving you a clear indication of where performance issues may be occurring. Within the Oracle environment, activities can be categorized as either active tasks, involving CPU processing, or wait states. Wait states encompass various scenarios, including resource-intensive operations like I/O, blocked processes, and even idle periods when the system awaits further instructions. Things to look for are what's the DB time, is the time on CPU or waits, if it is I/O related or non-I/O related. And what the queries are doing. Full table scan. Index contention. Latch, buffer cache contention. Excessive soft parsing, some hard parsing. Row-by-row processing. Global cluster waits. Almost idle servers. Open_cursors too high. Too large connection pool. Interpreting this section helps focusing the efforts on the most critical performance issues. By addressing the events with the highest total wait times, you can have a substantial impact on improving database performance. After analyzing this section, typical actions for resolution may include optimizing SQL queries that contribute to the most time-consuming events, tuning database configuration parameters related to the events, investigating potential resource bottlenecks such as I/O or memory constraints, identifying and addressing contention issues like locking or latch problems, implementing proper indexing strategies to reduce I/O related waits. Foreground Wait Class, Foreground Wait Events are grouped into classes. These include User I/O, DB CPU, Configuration, Commit, Other, System I/O, Application, Network and Concurrency. For RAC database, cluster classification of wait events can be seen. The following list includes common examples of the waits in some of the classes. User I/O, waits for User I/O, DB file sequential read, DB file scattered read, direct path read, direct path write, etc. DB CPU, time running in CPU, waiting in run queue not included. Configuration, waits caused by inadequate configuration of database or instance resources, for example, undersized log file sizes, shared pool size, etc. Commit, waits for redo log write confirmation after a commit. Other, waits which should not typically occur on a system, for example, wait for EMON to spawn. System I/O, waits for background process I/O. Application, waits resulting from user application code, for example, lock waits caused by row-level locking or explicit lock commands, TX locks. Network, waits for data to be sent over the network. Cluster, global cache operations contribute to this wait event classification. Concurrency, waits for internal database resources, for example, latches, HW locks. The Foreground Wait Events section of an Oracle AWR report provides detailed information about the wait events that foreground processes during the specified snapshot interval. Foreground processes are user or application-related database sessions that actively execute SQL statements and interact with the database. This section offers insights into the performance bottlenecks and the specific reasons for delays or waiting times in the database. They are associated with user sessions and typically occur in the context of a user's SQL statement or transaction. These events represent the time that a user session spends waiting for various resources, such as I/O operations, locks, latches, and other activities related to executing SQL queries and transactions. Foreground events are posted by sessions that have $session.type equals user, otherwise referred to as foreground processes. Look at his total wait time, SISI, which show how many times DB was waiting in this class and then wait average, MS. If total wait time, SISI, are high but wait average, MS, is low, then you can ignore this. If both are high or wait average, MS, is high, then this has to further investigate. Cluster events should not dominate the foreground wait times. Tuning the cluster interconnect and reducing the global cache transfer will go a long way towards reducing the effect of this classification. Background wait events. Background wait events are associated with background processes that are responsible for various maintenance and administrative tasks in the Oracle database. These events represent the time that background processes spend waiting for specific operations to complete, such as checkpointing, log buffer writes, log switches, archiving, and so on. Background processes include the database writer, DBWN, log writer, LGWR, checkpoint processes, CKPT, and others. Oracle background wait events represent delays experienced by background processes that perform maintenance and administrative tasks in the Oracle database. Background events are posted by sessions that have $session.type equals background, otherwise known as background processes. These events can significantly impact database performance. Time spent by background sessions, DBWR, LGWR, etc., is not included in DB time. Time model section shows some of the background statistics in the form of background elapsed time and background CPU time. Here's what you can typically find in the foreground and background wait class/events section. Wait class, this column lists the different wait classes, which group wait events with similar characteristics. Examples of wait classes include user I/O, concurrency, commit, system I/O, network, application, and administrative. Event, this column lists the specific wait events that foreground processes have encountered. These events represent different types of resource waits, such as I/O, locks, latch contention, network-related waits, and more. Common examples include DB file sequential read, log file sync, buffer busy waits, and CPU time. Total waits, the total number of times a session has encountered a specific wait event during the snapshot period. Timeout. Timeout typically refers to a wait event associated with sessions that are waiting for a specific operation to complete but give up waiting after a certain period. Total wait time, the cumulative wait time for a specific wait event across all sessions. It represents the total time that sessions have spent waiting for that event. Average wait, the average wait time for a specific wait event, calculated as the total wait time divided by the total number of waits. %DB time, the percentage of the total database time consumed by a specific wait event. It indicates the relative impact of the event on the overall database performance. Wait/TXN, waits per transaction. %time, %BG time represents the percentage of time spent by foreground processes waiting for background processes to complete certain tasks or activities. Wait event histogram. The wait event histogram section provides a graphical representation of the response time distribution for each wait event. It displays the response time buckets in milliseconds and the number of waits that fall into each bucket. The histogram helps you visualize the response time distribution, highlighting where most of the wait times are concentrated and identifying any outliers. It provides some idea about I/O subsystem the database is running upon. When an Oracle database spends a high percentage of its DB time on a particular wait event such as user I/O, DB scattered wait event, check the wait event histograms for each wait event occurrence is placed into a bucket or bin based on its duration. Oracle stores and displays the wait times in bins that grow by powers of 2. But even with the power of 2 bin sizing strategy, wait events can sometimes last many seconds or minutes. Do you see the 0.0 values in the less than 1 or less than 2s in one's bins? This means there was at least one occurrence. But since Oracle chose to severely limit the display precision, we can't determine how many occurrences. Look at the histogram built from wait event histogram data, $event_histogram and DBA_hist_event_histogram. Select event, wait_time_micro wait_count, wait_time_format from $event_histogram_micro where event like DB file sequential read order by event, wait_time_micro. Service Statistics section of AWR Report provides statistics broken down by DB time, CPU time, physical reads, logical read for the services. Service Wait Class section of AWR Report provides statistics broken down by some of the wait event classification for the services. Once you have identified the wait event, you can scroll down to the SQL Statistics section to identify the particular SQL_ID and its details. There are two common ways of collecting wait event information. The Oracle Extended Trace, 10,046 event, and using $views. Oracle provides a number of views to aid in tuning, a few are $system_event, which gives you total system waits for an event since database startup. $session_event, all waits the session encountered so far at the session level. $session_wait gives you what an active session is waiting on at that point in time. $session, which gives you session information and has a column row_wait_obj hashtag that tells you the object involved when joined with object_id or data_object_id in DBA_objects.